Hi friends, I am going to explain about the architecture of the 8086 microprocessor. In this, we have two major parts. One is the bus interface unit and another is the execution unit. In the bus interface unit, we have segments. These segments are extra segment, code segment, stack segment, data segment, and another is the instruction pointer. And extra segment is used to store the additional data, and code segment is used to store the program code, and the stack segment is used to store the stack memory, and data segment is used to data, and instruction point is used to store the prefetched instructions. And the it's summer, it is the address generator, 20-bit address generator. It generates the 20-bit physical address, and it has the queue. This means queue is the 6 bytes register, which stores the prefetched instructions. The bus interface unit is responsible for the data transfers, and the prefetched instructions is stored in this queue. The queue is operated in the system by using the principle of FIFO, that is first in first out. When the 20-bit physical address generated and the prefetched instruction is stored in the queue, and another is the execution unit. In this execution unit, we have four general purpose registers. These are formed by the two 8-bit registers, and the final register is the 16-bit register AX. AX is also called as accumulator, and BX, and CX, and DX. Here we have four special registers. SP is called stack pointer, BP called base pointer, and source index register and destination index register. And SP, BP are called pointer registers, and SID are called as index registers. The pointer registers are used to store the offset address of the data elements which are stored in the stack segment, and SIDI are used in the array processing and string operations. In this, we have ALU. ALU is used to perform the arithmetical operations by using the operands which are given by the programmer. And here we have flag registers. The flag registers, in this we have 6 status flag registers and 3 control flag registers.
Mm.
In this architecture, the data is transferred by using the buses. It has 16-bit data bus and 20-bit address bus. We multiplex the 16-bit data bus with the lower 16-bit address bus. The remaining 4-bit multiplexed with the status flags. Now I am going to explain about flag registers. In the flag registers, there are two types. One is the status flags, and another is the control flags. In the status flags, there is 5 flags. And first, zero flag, when the zero flag is to be set when the result is zero. And another is the sign flag, when the MSB of the word is 1, then is set, and otherwise it is reset. And third is the carry flag, when we get a carry in the result, then the carry flag will be 1, that is set, otherwise it reset. Fourth is the auxiliary carry. When we get a auxiliary carry, that is a carry from the lower nibble to higher nibble, is called auxiliary carry. When we get that, auxiliary carry will be set, otherwise it reset. And fifth is the parity. If we get parity in the result, it is to be 1, that is set, otherwise it reset. The overflow, when the result is very large than the destination, then the overflow flag will be set, otherwise it reset. And the status flags are used to the programmer to indicate the output status, that is the output is positive or negative or zero by through the 1 or 0 by showing the output. And another is the control flags. In the control flags we have three types. One is the interrupt flag, and another is the trap T called T flag, and another is the D flag. Interrupt flag, it is to be one when the microprocessor takes interrupt. Another the otherwise it reset, that is any interrupt can't do. Trap, the trap is set when the microprocessor provides a facility for the single stepping through a program. and another is the direction flag. The direction flag will be 0 when the processor working in the auto increment mode. Otherwise it has 1 when the processor working in the mode of auto decrement. The mean of auto increment is the processor working from the lower address to the higher address. Otherwise it working from the higher address to the lower address. The memory interface unit is used to access the memory and the input output port, and the bus interface unit is communicate with the other devices by using the memory interface unit. Now take one example program. Now take one example. Move AH comma 03. The 03 data is stored in the AH register, and the move AL comma 05. The 5 data is stored in the AL register. Now we give a command add AH comma AL. The contents of AH is add to the contents of AL. The answer will be stored in the AH register.